work in this area. To be invited into that collaborative process with the leaders in the field and to see your work literally take flight is a tremendously wonderful experience. At Western, students have the opportunity to work closely with faculty on projects that are typically reserved for graduate students elsewhere. And this has been a hallmark of Western experience for years now, not only in the sciences, but the liberal and fine arts as well. These kinds of hands-on experiences are invaluable for student learning, and they also contribute to the excellence and innovation of research, scholarship, and creative endeavors for years to come. What sets Western apart in this way? A huge part is the culture of engaged teaching excellence among Western's faculty, who are committed to making a difference in the lives of their students by bringing them into their worlds. Professor Rice is an exemplar. It also takes generous partners like you who see the potential impact of strategically investing in our students and their aspirations. I'd like to thank Professor Rice for the teaching and research excellence she brings to Western and for inviting her students to work on this fascinating research as part of her team. And I'd like to thank you for supporting Western and for the special relationships between students and faculty that change their lives, and in many cases, ours as well. It is wonderful to see so many of you I know personally on the webinar this afternoon. Thank you for being with us today and in the future. And now I would like to introduce our Dean of the College of Science and Engineering, Brad Johnson.
Thank you, President Randhawa. Thank you very much. And I'd like to add my thanks to everyone for logging on and attending today. And I bid you welcome. I'd also like to thank the entire panel for taking the time to be here today. It's an exciting time to be in the Mars business. I will be very brief because I know no one came to listen to me, including me. But I do want to echo the main points that President Randhawa made regarding both the style and substance of research at Western, and in particular in the College of Science and Engineering. As President Randhawa said, is it indeed a hallmark of what we do, and of the CSE education that students have the opportunity to participate in an authentic experience, working directly with faculty in both genuine and primary roles. I'm sure many of you in the audience have seen or heard some of the many inspiring stories centered around our students and their experiences making opportunity and dreams come true, theirs and ours. In addition, I want to mention that the CSE community has as a fundamental strategic goal to connect more broadly and more deeply with the larger community that we are part of. This goal and idea goes beyond our primary mission. That is, to educate students and provide them with an array of skills, engagement, and opportunity that will serve them as they graduate and join that broader community. But it also includes the direct impact of the work we do at Western on local and regional partners, industry, municipalities, and people in general. As a part of our planning and execution, we are always on the lookout for individuals who share that interest, and also for fields of endeavor that provide opportunity for broader engagement. Several years ago, we made the decision as part of the introduction and construction of a BS degree in geophysics to build a program in planetary science, which is a field of great interest and import on its own, and also a field with a burgeoning public and private presence in the greater Puget Sound region. At that time, we were also incredibly fortunate to cross paths with Dr. Melissa Rice, who not only is an accomplished scientist and researcher, but someone with a passion and considerable talent for outreach and community engagement. In fact, she's one of our most gifted and proficient educators with a focus on broadening and deepening our community connections. Now, with that segue, I want to introduce you to today's panel. First of all, it's my distinct pleasure to introduce to you Dr. Melissa Rice. Melissa joined the faculty at Western in 2014, serving in a joint position spanning the Department of Physics and Astronomy and the Department of Geology. Prior to joining Western, Melissa earned a bachelor's degree in astrophysics from Wellesley College, master's and PhD degrees in astronomy and planetary science from Cornell University. Subsequently, Melissa earned a NASA postdoctoral fellowship at Caltech. Joining Melissa on the panel today are the following students and alums. First of all, Darian Dixon completed a master's degree in geology in 2018 and is now at Malin Space Science Systems. And Darian began his graduate career at Western during the summer of 2015. So he was involved in the Mars lab after completing his BS in geoscience at the University of Wisconsin-Milwaukee. Next, we have Kathleen Hosa, MS in geology from Western in 2019, now at First Mode, a Seattle-based company. Kathleen was a graduate student that worked with the Western Mars group since between the summer of 2017 and her graduation in 2019. Next, we have Amanda Rudolph, who earned a BS in geology in 2018 from Western and is now pursuing a PhD at Purdue University and was part of the Western Mars group starting in the spring of 2017. Next, we have Tina Seeger. Tina is a current graduate student, a first-year student studying geology at Western, and she's a part of the current Mars group. She joined the Curiosity team after completing a BA in geosciences and astronomy at Williams College. And last but not least is Catherine Winchell, who earned a BS in geology in 2017 and is now also at the Malin Space Science Systems. Catherine worked in the WWU Mars lab between 2014 and 2017 and was a part of the initial group working on the Mastcam-Z. So we'd like to begin the main part of the webinar now, and I want to encourage all of you to type in questions into the Q&A section as we go. But I'd like to begin with some specific questions for both Melissa and for the panelists in general. And let me start with you, Melissa. First of all, how is this mission, the current mission, the 2020 mission, different from NASA's previous Mars rover missions?
Yeah, thank you, Brad, for that nice introduction, and so great to see all of the students in a reunion on the screen here. I know we're all really excited about this mission because it's bringing some brand new technology and goals to NASA's Mars exploration program. And we're going to be doing some things on Mars that have never been done on another planet before. This rover mission is carrying with it a helicopter. It's going to be the first spacecraft to fly in the atmosphere of another planet. So that is a really exciting technology demo. We're also preparing the groundwork with this mission for the next 10, 20, 30, 100 years of science and human exploration on the surface of Mars. This mission is really not just going to Mars to do an investigation on the surface to study Mars as the previous rovers have done, but this mission is for the first time collecting very well chosen, well characterized rock samples from the surface of Mars to be brought back to Earth for investigation in Earth-based laboratories. And that's what has to be done in order to really get the next giant leap in our understanding of Mars and the solar system. So if it's all right, I'd like to share my screen and show some of the things that I'm really excited about in this new rover mission. So let me show you a few graphics here that I think will, in some cases, speak to themselves. So here is an artist rendition of our new rover. This rover has a name now. For a long time, we've been calling it Mars 2020 for the year when it would launch. And just a few months ago, it was given the name Perseverance. Now, this name Perseverance came before COVID, before we really knew what we would have to persevere through. So the name wound up being incredibly appropriate for a spacecraft in the last stages of getting to the launch pad in the midst of a global pandemic. And what's different about Perseverance from the Curiosity rover or anything that's come before are a few giant leaps in its technology that it's bringing with it. And what I want to highlight here are what's labeled the sample caching system. That is going to store and prepare rocks that are prepared by the turret. The turret is the suite of instruments and components on the end of the rover's arm, and that is going to drill core samples from the bedrock on Mars and then put that into sample tubes that are within the sample caching system, and then leave those sample tubes on the surface of Mars, prepared, sealed, and ready for NASA's next stage to bring those back to Earth. So here's what that will look like as the rover is preparing these samples to be left on the surface of Mars. And then it's going to require a new mission, which is in the beginning planning stages to launch to Mars in the middle of the coming decade. And that's going to be another rover designed specifically to pick up these sample tubes, launch them, bring them to a launch pad, and launch them into orbit around Mars. And that's not all that's required. After that, probably in the early 2030s, if the timeline sticks to what has been proposed, there will be a third mission that rendezvous with those samples in orbit around Mars, grabs them from orbit around Mars, and brings them all the way back to Earth. And again, this is really what we have to do to make our big leaps in understanding the history of the geology and potential for life on Mars. We really have to get these rocks back to Earth, back into Earth laboratories where we can use the most advanced, highest fidelity instrumentation in order to do tests to see if there are biosignatures, which are definitive signs of life associated with these rocks preserved on Mars's surface. Other things we're really excited about are the Ingenuity Helicopter. This is the technology demonstration. This is going to be NASA's Wright brothers moment of flying for the first time in the atmosphere of another planet. So this is a small helicopter. It's about the size of a CubeSat. So maybe the body is about this big. It has two blades, and the blades are enormous because Mars's atmosphere is so thin. The blades have to be very large in order to produce enough lift to fly in an atmosphere that is 1/100th the thickness of Earth's atmosphere. So this helicopter is going to be folded up like a little origami piece underneath the belly of the rover when it lands on Mars. And then it's going to deploy, it's going to drop onto the surface, the rover will drive away from it, and it will fly for the first time on Mars. But what the students and I have been particularly involved with over the year, our little slice of the pie on this mission is the Mastcam-Z instrument. And Mastcam-Z is at the top of the rover mast. It's these two eyes underneath the giant round Cyclops eye. Mastcam-Z are the color cameras. The Z stands for zoom. So these two eyes, for the very first time on Mars, are going to zoom into incredibly high resolution so that we can see the details of what's in the distant landscapes as we're driving around on the surface. So the Curiosity rover had some similar cameras that myself and the students have worked with as well. And you can see that Curiosity's eyes were kind of lopsided. That's because one eye was zoomed all the way in. It was essentially a telephoto lens, and the other was zoomed all the way out. It was a wide angle lens. Mastcam-Z, for the first time, is going to have two cameras that can zoom all the way in or all the way out for high resolution stereo or high resolution or wide angle stereo imaging. So we've been involved with Mastcam-Z since 2014 when I arrived at Western. And this is what Mastcam-Z looked like. I forget if this is the left or the right twin, but we've been involved since they've been in the design stages and the early build stages at Malin Space Science Systems. And since then, two of the students that we'll hear from, Darian and Catherine, have gone on to work at this company where Mastcam-Z was built. And then we've seen them through their testing as they were finalized before they were sent to the Jet Propulsion Laboratory to get mounted onto the rover. And a group of us last May flew down to the lab to be part of the testing. And you can see the Mastcam-Z cameras in the clean room behind our group here. And two of the engineers in their bunny suits in the clean room involved with the testing of the Mastcam-Z cameras. We took some several 100,000 test pictures with those cameras in the span of a few days. And here's a picture actually taken by the Mastcam-Z cameras. This is the science team who was involved with the testing. And I had already flown back to Western to teach my Friday class by this point, but they were kind enough to let me Skype in, and somebody held up a laptop, and I'm actually the only person who gets to be in this image twice. If you can see me, my image reflected in the mirror down here, and then in another mirror up top here. So this is an actual picture from the real cameras that are now on top of the rover, and the rover itself is on top of its rocket on the launch pad, ready to go. So we've had a long history of involvement at Western and various stages of the camera. And in January, we went down to the Jet Propulsion Laboratory and got to see the rover itself in its final stages of being assembled and tested in the clean room at the Jet Propulsion Laboratory. And so here's our crew with the Perseverance rover in the background in the clean room behind us. And we've got a model of the Mastcam-Z camera that some of the students are holding in the center there. So it's been a long journey for us. And we've also been able to invite the whole Mastcam-Z camera team, which includes scientists and engineers from around the world. We had some of our engineers and scientists fly in from Denmark, from California, from the East Coast, from all over the place. And we hosted them for a team meeting here at Western and took the whole team up on a hike to Easton Glacier on the side of Mount Baker. So that was a highlight for a lot of our team members. And as part of that, we did our part to engage the local Bellingham community as well. Since we had all these prominent Mars scientists descending upon Bellingham for a few days for this team meeting, we held an event for the entire community at the Mount Baker Theater. We called it the Mars Invasion, and we had a sold-out show. We had nearly 1,000 people crowding the Mount Baker Theater, and we had a panel conversation with scientists and engineers involved in the Mars rover missions. And so here's the landing site for where Perseverance is going. And I just want to show you one last thing, which some of my current students have been deeply involved in, which is the effort to map the landing site. So right now we're in the final stages of our strategic process of planning what the rover is going to do when it lands on Mars in February, opens its eyes and decides where to go next. We're laying the groundwork right now by creating maps from the images that we have from our orbiters. And the way that the team has done that is they've taken the entire landing area here, and you can see that it's divided into a grid. And there's a grid of some 300 squares here. And each team member was given one or more squares to create a map. And then that map, each of those individual squares were patched together like a patchwork quilt. And so I have 2 squares that I mapped that are part of this. And some of our current students have their own map pieces that are patched as part of this collaborative effort. And this has just been submitted for peer review publication as well. So we've been involved in the cameras. We've been involved in the strategic planning process for what the rover's going to do. And we've been involved in the community outreach to get the word out and share what all is different about this mission from what's come before. So Brad, that was a long-winded answer to your question, but hopefully we got some of the overview and background material out of the way, and we've got a lot of good images here that hopefully will spur a good Q&A later on.
Yeah, thanks, Melissa. I appreciate that very much. And then I have a follow-up for you that you answered a lot of, but I just will give you a chance to just briefly fill in any gaps about over the past 5 years, what has been Western's role in preparing for the rover mission. Again, I think you answered a lot of that, but if you have any gaps you want to fill, now's your chance.
Yeah. Well, I think we've seen that our involvement has been focused on the planning and the development and the testing of these 2 cameras, the Mastcam-Z cameras. And we'll hear from some of our students who are still working on those cameras and getting ready to operate them once the rover lands and opens its eyes on the surface of Mars. But I'll also add that we've had about 25 students in the past 5 years at Western who have contributed in one way or another to the development of this mission, to the selection of the landing site, to the mapping of the landing site and the preparations for what we're going to do on Mars. And so we've had a big impact on the mission. And I think what's really unique about Western's contribution is that we've done this primarily as a group of undergraduates and master's students, whereas the vast majority of students who get to be involved in this process are PhD students at R1 universities. So that's been something that's been really neat for me, is to bring undergraduate students kind of on the start of their academic journey into this process.
Yeah, thanks. Well said. That's a very important point. Thank you. So my next questions are for the students. And what I think I'll do is I'll ask a question and I'll go around and let the students answer this, and we'll move right from there. And when we're done with the student questions, we'll move on to the Q&A, just so everyone's aware of where we are here. So first question for the students. How have you contributed to NASA's Mars rover missions to date while at Western and elsewhere? And what will your role be for the Perseverance rover when it lands in February? So let me just go around and let me start with Catherine.
Yeah, I started at Western in 2014 when Melissa's first student. She put me on doing multispectral research with spirit data. So one of the precursor rovers to Curiosity even. And from there, I moved on to doing some mapping for the landing site selection for 2020. So before that beautiful map that she was showing earlier was done, there was about 20 sites that we had to narrow down and only choose one from. So I assisted with that. After graduating, I went to Malin Space Science Systems, where I've been operating the mast cameras on Curiosity. And I've also been involved in preparing for the 2020 mission. I got to be one of the people who was in the clean room with the cameras as we were doing calibration testing, which was a really amazing experience. And when 2020 lands in February, I will be one of the people who is operating Mastcam-Z.
Excellent, thanks. Darian, same question.
Yeah, so I started working for Melissa as a master's student in 2015. My research as a master's student revolved around how we could use these cameras to identify hydration in minerals on the surface of Mars, how we could use Mastcam-Z to accomplish that. Because one thing that's really cool about Mastcam-Z, these are spectacular cameras. They don't just take traditional images like most people think. They also see in different wavelengths of light, slightly beyond human vision. And those different wavelengths of light can interact with different materials in different ways, and we can actually use that to figure out what that material might be made of. And so my research was looking at the camera's ability to detect signs of water in certain minerals on the surface with those camera properties. And that was really cool and a lot of fun. Got to go to team meetings and present research, got to travel to JPL and meet a lot of people. And it was just really exciting to contribute in that way and to be able to do those things. And now at Malin Space Science Systems, working with Catherine, kind of doing a lot of similar things, working on the Curiosity rover, a little bit less these days, doing more 2020, but also working on the Curiosity rover and operating. Was also in the clean room for calibration and for testing the cameras, wearing the big white suits and sitting next to the cameras. It was a lot of fun. And now a lot of my effort is on getting ready for Mars 2020, getting set up to operate it and getting set up to use that for the next stage of Mars exploration.
Great, thank you. And Kathleen, same question.
Yeah, hello. So I started my involvement with Mars rovers back in 2014 when I was still working on a bachelor's degree in aerospace engineering. I spent about a year as an intern at JPL working on the Curiosity mission. I was developing a workaround for an error with the drill mechanism that Curiosity was experiencing. we used the drill in a different way than was standardly expected, and were able to bypass some of the shorting out circuitry. That strategy ended up being one part of the plan that was used to keep Curiosity drilling recently up through the present. So that was my initial experience with it. Came to Western to work with Melissa specifically because I loved that mission and wanted to continue working on it. And Melissa gave me that opportunity to do that in a completely new way. Got to become part of the science operations team. Had an experience, which I think almost all the students on this call did, of being the geology keeper of the plan as part of the day-to-day operations of the rover. It lets you, as a student, be involved in the day-to-day decision-making that scientists are making about like what rocks Curiosity is going to look at next and what science questions they're going to try to answer today. And then also was able to work on a project for my master's thesis that let me combine my engineering background with the science questions we were trying to answer. I'm going to quickly share my screen because it's hard to explain without images. So the question that we were trying to answer is basically how Curiosity's spectral data taken of target materials might vary with the viewing geometry, which is the relationship between the light source, like the sun, and then the detector, like Curiosity's Mastcam or Mastcam-Z on Perseverance, and then the target material. So what I did in the lab with Melissa was created an instrument to basically mimic that. This incidence arm has a light bulb, and you can move it around like the sun moving across the sky. The emission arm has a detector, which you can move around like Curiosity, looking at a rock that's closer or farther away. And then this has different samples. So this was not a direct involvement with the mission, but this data that we collect in the lab here helps us to understand what's going on with Curiosity's data that it's collecting on Mars. Then now I've continued along that path, working on basically an upgraded version of that instrument. Now, instead of being restricted to a single plane, we're able to measure differences in azimuth as well. So that's the current project that I'm working on that will be used to help interpret Perseverance's data, as well as going back to Curiosity's.
All right, thanks. Great, yeah, thank you. Next, Amanda, same question.
Hi, so I started working with the Western Lab Group in the spring of 2017, and I come from a geology background, so I was doing a lot of analog work, where a lot of what we know about the rocks on Mars, we learn from what we know about the rocks on Earth, so analyzing different rocks that we see here that we also see on Mars and how they've been altered using like the scanning electron microscope that we have on campus and the X-ray diffraction instrument, and as well as analyzing some of the multispectral data that's been brought down from the Curiosity rover. And I'm now pursuing my PhD at Purdue, and so at my time here, I've joined the ranks of the Geo Keeper of the Plan, as Kathleen described, working on rover operations. And one thing I'd like to say about that is every time I've been on shift with this, I've seen one other person from our Western Lab Group on there, and that's always like an exciting time of, oh, hey, I know you. Look at us still doing cool science together. And I don't have a specific role in the Perseverance rover. I'm working mostly with Curiosity data, but I was able to attend one of the landing site workshops where people gather teams and are advocating for where should this next rover go to answer these new compelling science questions that we have about Mars. Yeah.
All right, thank you, Amanda. That's awesome. Thanks. Tina, same question.
Great. Hi, everyone. So I graduated from undergrad in 2016, and then I spent 2 years working as a lab technician at Caltech, and that's when I began my Mars rover journey on Curiosity, mostly as keeper of the plan, but that was kind of the first taste I got of getting to work with rovers. I double majored in geology and astronomy in undergrad, and then realized I could look at rocks in space with rovers, and it was the perfect combination for me. So I had a lot of fun with that, got to go to one of the earlier Mars 2020 landing site selection workshops while I was down there, and really got to dig into doing some research with curiosity data, which led me to realize that I wanted to pursue my own grad level research. So Melissa was an easy choice for me to come to Western and work with. I wasn't really sure if I was ready for a PhD, so the master's only option at Western I think is really unique and cool because you get all of the research opportunities that are there because there are no PhD students to scoop those up from you. And it's a great way to kind of formulate, research, execute, and write up a project in 2 years. So I've spent a lot of my time continuing my operations role with Curiosity. My whole master's project is centered around Curiosity, using some of those multispectral images that we've talked about. I've been looking at all of the multispectral imagery we've taken over the past 7 years with Curiosity and seeing what kinds of signatures I can see in the different rock types that we've investigated over the whole almost 30 kilometers that Curiosity has driven. And so I've also, even though it's not part of my main project, gotten to work on Mastcam-Z, doing some of the calibration. I went down to San Diego and it was fun to have a little bit of a Mars lab reunion during calibration for that instrument, as well as doing some exercises for preparing us for operations. Since I have a lot of operations experience, we have done a couple exercises where a group goes out into the desert and pretends to be our rover, and they'll take pictures, and then we will be our operations team on the other end of the line and tell it, you know, where to drive, and the field team will pick up their stuff and walk over and take our pictures. And so getting a great Mars analog site and trying to smooth out and streamline our operations process so we get good practice. So when we actually are on Mars, we don't have a field team, we can ask, you know, what was that rock really? We'll be ready. So that's been great. And being at Western for 2 years doing this research answered the question for me in a big way. Do I want to do a PhD? Turns out yes. So I will be defending my master's in 2 weeks. And then this fall, I'm heading back to Caltech to do my PhD down there. And I'm really excited. I timed it well so that when we land in February, I'll basically get to shape my PhD project around all of the really cool geology we're going to see in Jezero Crater. So I'm super excited for that.
That's awesome. Thanks, Tina, and congratulations on your defense.
Thank you.
So my next question is for all of you again, and if I could get you to briefly describe how your education at Western helped you to get where you are. I think a lot of us would be very interested in that. Let me start again with Catherine.
Yeah, I absolutely would not have the job that I do have if it wasn't for Melissa being at Western. A huge part of any industry really is, you know, about experience and what connections you can make. And Melissa gave all of us such a wonderful opportunity to get involved with a mission, as you just described. I met my current boss at that Mastcam-Z team meeting that was at Western, and just every single experience that Melissa brings us in being able to do work with the mission allows us to then go and share our work with people who are in the field, and that's what allows us to get to know people who can provide us with jobs and other opportunities to move forward with our careers.
Great, thanks, Catherine. And Darian.
Yeah, kind of want to echo the same thing. Everything about my education at Western prepared me for where I'm at now, from you know, getting to go to team meetings, getting to go to JPL and participating in so many things that I didn't think I ever would be able to participate in. And you meet an amazing number of people, scientists, people that work on the mission, engineers, in all levels of the project that you never thought you'd be able to meet. and being able to do that and being able to be involved on that level was, that was amazing. That prepared me a lot. I think going in, you know, I knew what I was coming to do. I knew I was going to be working with Mars rovers and working in space science, and I was excited. But there's kind of this, like, I kind of had this thought in the back of my head, like, oh, well, I'm just going to be a master's student, you know, like I might not be too involved in a whole bunch. I might not meet a lot of people. I might be relatively unknown. And with Melissa, there is not that. It's like all in immediately. You get involved in stuff, you get taken places, you get to see and do things that, like Melissa mentioned earlier, people don't typically get to do unless they're PhD students. And I think that was just an amazing experience. It really is just, you get thrusted right into the thick of Mars science, and that opened up a tremendous amount of doors for me and for all of us.
Perfect. Thanks, Darian. Kathleen, how about you?
Yeah, so there's a really obvious example of how my Western experience got me to where I am today in the goniometer, which is the instrument that I showed before. The master's thesis version of it that I did was part of a pilot study that Melissa used to get additional funding and go to a company in Seattle called First Mode, which provides engineering for spacecraft and other applications as well, and say, hey, can you make me an upgraded model of this goniometer? As the grad student on that project, I went down with Melissa to talk to the engineers there. Had a great experience and ended up applying and working there now on that 3D goniometer. So that's clearly a very direct link. But I've also had an ability to continue to use a lot of the stuff that I learned at Western on other projects at the company. And Melissa's willingness to take someone with a different background. I had an engineering degree going in. So in her willingness to let me come in and learn that second set of skills has really helped me to have a more diverse background than most people that I work with. And as a specific example, I've been part of a group that's working on a proposal for the next crewed lunar rover. And as part of that, we need to decide what slope traverse capabilities and what range we should give the rover. So I was tasked with going around and identifying promising science targets near the landing site, and then mapping out traverses to those sites and figuring out what slope and what range we would need to be able to access those things. So Western giving me the opportunity to get both sides of the picture, both the science, being able to identify those science targets, and then being able to talk to the engineers as well, has been a really great opportunity that has been really positive for me.
Great, thanks, Kathleen. How about you, Amanda?
So I will be echoing a lot of what has been said in the fact that my pretty much whole career path has emerged because of the time that I spent here at Western, and specifically through the mentorship of Melissa, and as well as Dr. Mike Kraft, who works at Western as well. Both them and the whole geology department have provided me with tools to become a true field geologist and then apply that to other planets, both with the research that I was able to do as an undergraduate, which is, as for the master's, PhDs normally have the big juicy research projects, masters get the second juicy, and then undergrads are kind of picking up the scraps, where I was able to dive deep into some very interesting research. And they set me up perfectly for the research that I'm doing as my PhD. And along with that, Melissa introduced me to my current PhD advisor, and I may not be where I am without that introduction. And even further, just the mentorship relationship that Melissa has formed, I think with all of us, is something that I know is going to continue for years to come, and I could reach out at any point and ask for help or guidance in the future. And that's unique and rare, and I'm very grateful to have that relationship.
Great, thanks, Amanda. Tina, how about you?
Absolutely. I think for me, one of the most important parts of my time at Western has been the way it took me from, I had this background working with the rover already, but just kind of an interest in it and some undergrad research experience, but not really knowing how you conceptualize and create and complete a research project. And so coming to Western and doing my master's here has been so instrumental in kind of taking that next step as a research scientist and really growing as someone interested in academia and somebody who wants to continue on this path. I feel worlds ahead of a lot of my colleagues who go straight into their PhD programs, although many like Amanda are extremely successful. But having that preparation, at least personally, I think had I just jumped straight into a PhD program, I would have gotten there eventually, but the way that I feel ready to hit the ground running and the opportunity I have to hit the ground running right as the Perseverance rover hits the ground driving is really unique and really special. And I feel so well poised to kind of pick up and run with that because of the time that I've had at Western, working with Melissa, working with the community of our lab group, to be able to like formulate collaborations and kind of follow my research project through to completion. So that has been really instrumental. I also think just getting to spend the 2 years at Western with all the opportunities that I've had to go to team meetings and travel and meet with different people, it allowed me to kind of redefine my role on the Curiosity rover team. You know, instead of someone who's just the keeper of the plan, through some of the work that I've been doing over my master's, I've been giving more science discussion talks to the whole rover team. They could just call in and listen to me talk about the science that I've been doing. And so having that opportunity to transition into more of like a scientist role and have more things to say about the actual geology has been really, really cool. And I think really set me up well to jump into this PhD and really be on the science side of things and take those next steps. So that has really helped change and shape things for me.
Great, well said, thank you. And then lastly, for the group at the moment here, I'm certainly interested in this next question, and that is, what opportunities would you like to see Western offer for future students who are interested in space exploration? Let's start with Catherine again, thanks.
Yeah, this is something that I've thought a lot about, and there's two things that I've come up with. The first is just allowing Melissa to continue to have funding for student research. This is something that we all talked about. You know, we wouldn't be where we are without being able to do that research. And it's somewhat of an equity issue across all of STEM about whether or not students can afford to spend their time doing research rather than spending their time working a job. So having that money so that you're earning from research rather than earning at Starbucks allows students to have time to do this and advance their careers. And that's just something that is so crucial. The more that I've thought about it, I was fortunate enough to not worry too much about financial things during my degree, but just for the future, I think it's something that would be really valuable to Western's program. The other thing, something that surprised me, and I think many people who go into the operations side of things, I apologize, we're about to have a San Diego military plane fly over, it might get a little bit loud. I did not know all that much about how cameras worked going into this job. I knew the science side of them, but I didn't know so much about like how filter wheels and all that actually function. So I think that planetary science is an incredibly cross-discipline field, and having something, building more working relationships with other departments at Western. I know that Western has a photography program, and seeing about if there could be, you know, even just a seminar that's possible to help the planetary geology students get that cross-discipline information, that learning Python, yeah, those are the main things. Extra engineering, technical type things in addition to our geology degrees.
All right, noted. And I couldn't agree with you more about the equity piece, and that's something that we really think a lot about over here in the college. So thanks a lot. Darian.
Yeah, I think first and foremost, just a whole lot more of the same. What Melissa does and what she's been able to do is awesome. I see that the Mars group is growing. It was smaller when I left, and you know there was like a designated space that got set up when I left, and I came back a little bit to visit not too long after, and there were all these students I'd never seen before, and the room was all decorated, and there were nice new computers. It's just awesome to see it growing. So just continuing to do more of the same and continuing to grow is fantastic. And what Catherine said about funding for research and the equity component was something I wanted to say also, because I think that's a huge part. When I was Melissa's master's student, you know, I was fortunate enough to have funding for research to where I could get paid to do my research, and that enabled me to do, I think, a lot more than I would have been able to otherwise. That enabled me to focus more on my research, focus more on my work, and have the opportunity to participate in some of these extra things that were, you know, a little outside of my thesis, but helped lay the, you know, the framework for my future career. And when I was in grad school, you know, I had a lot of friends in grad school back home that went to either stayed at University of Wisconsin-Milwaukee or went to different institutions. And some of them had a very different experience with that. You know, I had friends that they were doing research and trying to get their thesis done and trying to find more opportunities to expand their skills and participate in different things in their fields. But, you know, they run into situations like, oh, I really wanted to go to this conference or this meeting, but I got a shift at Subway, so I can't go. And, you know, situations like that make it very hard for people to participate in everything that's available to them. So that's a big component.
Great, well said. Thanks, Darian. Kathleen, please.
I'm definitely going to be echoing a lot of what was already said, but mostly I would like to see some of the things that Melissa already does a really good job of become more official policy at Western. Specific examples, mentioned I come from an engineering background. Melissa was ready to look at my application and see that, like, even though I didn't come from a straight traditional pathway from a geology bachelor's degree, I might have something to offer, and I might be able to be successful and have it be a good experience for everyone. I would like to see that continue, not just for, like, you know, an engineering background, but someone who has a different background for any reason, whether because of like how they grew up or what they did or whatever. There's all kinds of different people, and I'd like to see Western being ready to be flexible as they look at their applicants for like across different programs. Then additionally, as has been mentioned, I do think funding students to be able to do their research is incredibly important. Melissa does a really good job of looking around and seeing where she can get funds so that her students can get paid to do their research and not have to have an outside job. But right now it's dependent on what your professor does for you, rather than being something that Western necessarily provides. So I'd really like to see like guaranteed funding for students doing research. And then finally, just more students able to do the kind of research that we all have the opportunity to do. I vaguely remember at one point, I think Melissa had like 40 applicants for 3 research positions for undergraduates. That might be wrongly remembered, but I don't think it's far off what the actual numbers typically are. There's far more student interest than what one professor can reasonably support. So I'd just like to see the program get bigger.
All right, perfect. Amanda.
Yet again, I'll be echoing some things that have been said. I mean, in a perfect world, we could just copy and paste Melissa over and over, but unfortunately, we're not quite there yet. I do want to emphasize again, just funding for students, whether it's in the form of like an endowment for a lot of internships that people are offered, even if it's not through Western, but a summer internship that can help mold their careers, a lot of them may not be funded. So allowing students to travel to these internships or travel to these workshops and conferences is essential. And that is a big barrier for a lot of students because they can't afford to not like work their job to pay their bills, to help their family type of thing. So just want to emphasize that again. And on maybe a lighter note, it would be fun and helpful if there were more like organized field courses specifically for like planetary science, because Washington is right full of fantastic geology and specifically for planetary science. Within our lab group, we've gone on field trips to like the Columbia River flood basalts, which are just a couple hours away, which I grew up next to and didn't realize what I was growing up next to. So this is a good chance to expand on what we see every day that we can bring to the table.
All right, thanks. Love it. All right, thanks. Tina.
Yet again, echoing how important student funding is, since I think that's been talked about well. The only other component that I'll add that Amanda kind of touched on is not just being able to fund students to do their research, but how important travel to things like conferences can be. I was very fortunate in my undergrad to have the school pay for me to go to a couple of conferences, and being able to present research that I had been working on or have networking opportunities at those conferences was majorly influential in getting me the position that I got at Caltech, and then, you know, cascaded, met Melissa, et cetera, through. And I think especially for undergrads, the caliber of research that they do in the Mars lab is like absolutely something that needs to be put out into the scientific community. And getting conferences on your resume is huge, especially for students who want to apply for jobs or apply for grad school in particular. So I think, you know, the more we can get students getting their research out there, because the students in this lab group are doing incredible things, and I've been blown away by the undergrads that I've worked with. You know, Melissa has done an amazing job of saying, hey, like the Lunar Planetary Science Conference is coming up, and it's really an important conference for our field, probably the top conference for our field, and seeing like who wants to go and then how can we all get there. And that's been so incredible, and I know it's like a really important experience for a lot of students. And so being able to keep that a priority too, not just getting funded for research, but having students have the opportunity to do that travel and go to the, because conferences are really expensive. So getting to have that chance to get their research out there is really, really special and important. The only other thing I'll add is kind of a long-term dream for planetary science at Western. Mars is amazing, and we have like the best data of Mars for geology, but there are so many really cool bodies in our solar system. And so it's so special that we have the Mars lab, and I think that's absolutely incredible. And I would love to, you know, be able to branch out and have more people working on different planetary bodies. You know, in 2034, we're going to be sending Dragonfly to Titan, which is going to be this amazing mission that's going to see so many cool new weird geology on Saturn's moon Titan. And so I think I would love to have Western just build out planetary and have more avenues to explore all the amazing things in our solar system, because even just having that link between the geology and the physics departments is really unique, and gives a lot of students a lot of opportunities to explore problems from different angles. And so someday I would love us to have a huge planetary department tackling all of the problems in the solar system.
That's a great ambition. Thanks, Tina. I'm kind of a big Europa fan myself. So yeah. Anyway, the next question is for Darian and Catherine, because of your work at Magellan Space Science. So we're curious, how is Magellan Space Science Systems getting ready to operate the Mastcam-Z on Mars? Darian, why don't you start?
Yeah, so things are ramping up pretty quickly here. We're going to be launching soon and landing in February 2021. So it's really exciting times. There's a lot of people working on a lot of different things, and operating a rover is a lot of work. It's a really complicated, involved, in-depth process. And so part of getting ready for that is a mind-numbing amount of testing. We want to test absolutely everything from the actual hardware on the rover to the software we use, to also just personnel things like how we do things, what are our protocols, what are our tools that we're going to use. And so all across the board, we're doing, you know, constant testing on all three of those avenues, and really figuring out how we want to do things, what our camera is capable of, what's most efficient for us, how can we better serve the science community, who are kind of like our clients as we operate the rover and we take the pictures. We want to, you know, do things in a way that supports science so that they can do the best science possible. And it's a lot of coming together and really figuring that out and building it partly from scratch, and then partly relying on everything we've learned from curiosity. And so far, it's been a tremendous effort. It's been a lot of fun, and yeah, just we're doing an incredible amount of testing over here in San Diego.
All right, Catherine, what would you like to add?
Yeah, Darian covered really well what we're doing right now, so I'm going to take a step back to when we did calibration testing, because that was a really amazing experience that a lot of us from Western who are currently at MS-Cubed and current students at Western were involved with. For those of you not familiar with what calibration testing is all about, basically we want to see what the little quirks are of these particular cameras that we're sending to Mars. So we were taking photographs in different conditions of dot targets, which are whiteboards with dots all over them, rock targets, all that kind of stuff. And it was really cool to get to be in the same room with these cameras that are going to Mars, because up until this point, there had always been kind of this disconnect with me between like, okay, yeah, you know, I've got this data from Spirit, I'm analyzing it, and yes, I'm sending this stuff to Curiosity, and of course it's amazing and it's mind-blowing, but there's something about it that like you can't fully grasp until you are sitting in the same room with these cameras and looking at them and hearing the filters move as they change positions. So that's something that's such a unique experience of being there for, I wouldn't call it the beginning of the mission because it's really the middle. The beginning was long before I was in college even. But getting to interact with this hardware before it goes to another planet forever has been such a wonderful thing.
That is exciting, thanks. So for Amanda and Tina, so you both have ambitions to finish your PhD. So I think we're curious, you've answered a little bit, but I'm more interested in the specifics of your PhD research and where do you hope to go after graduate school? Why don't we start with Tina?
That is an excellent question that I wish I had a very easy answer for. I think that something I've learned over the past couple of years is how much I enjoy research. And so I, you know, for some of my thoughts are kind of heading towards working at a place like JPL as a research scientist, getting to really like dig in with these rovers and different missions and getting to, you know, do the cutting edge science where it's happening. That's pretty special and amazing to think I have the opportunity to think about career paths like that. But I also have been thinking about academia a lot. I really enjoy mentoring and the kinds of relationships that you can build in a lab group. And the opportunities that I've had to mentor some of the undergrads in our lab as a master's student have been really cool. And so that's something I'm looking forward to exploring more in my PhD. And science communication is really important to me. I actually work at Mount Rainier National Park as the dark ranger. So that's why I'm in uniform. I'm gonna have to run back down to the desk to help visitors kind of connect with their park in just a few minutes. But I primarily run our astronomy program at Mount Rainier with all of our telescopes and doing astronomy. So yeah, connecting people with science has always been really important to me and something that I love. And so going into a position like a professorship kind of gives you the best of both worlds, because you get that teaching component, that mentoring component, and Melissa has shown me that you still can do the cutting edge science while you're also doing all of those other things. And so that's kind of high on my list as the direction that I might be heading.
Perfect, thanks. And how about you, Amanda?
All right, well, I'll start with what I'm studying for my PhD research. I'm a couple years in, so my dissertation is a little more lined out at this point, but still not completely. I am taking kind of a holistic approach and looking at multiple viewpoints of Mars, both from the surface, from orbit around the planet, and then back here from Earth, in order to better interpret the geologic history of Gale Crater, which is where the Curiosity rover is at right now. So starting from the surface of Mars, because why not start on the super cool planet? I'm looking at a particular region named Glentordan, and this region is interesting, and it's one of the main reasons why Gale Crater was chosen as the field site for Curiosity, and that's because of clay signatures that were observed, well, from orbit, and that have been seen since the rover has explored the region. Clay is a super important find for planetary science, and that's because in order for clay minerals to form, water had to have been present. It's within the structure of the mineral, so there's no way around it. Water was here at one point, and when you're looking for ancient habitable environments, we rely on the idea of following the water, so this was just a great spot to go. So I used data from the camera eyes of the rover, those multispectral images, to look at rocks at like a meter to tens of meter scale. I constrain their composition and look for different physical features that provide insight to any alteration that occurred to these rocks after they were deposited. And then zooming out from orbit around Mars, my other project is studying an area that Curiosity will be visiting in the near future. So there are these unique dark rock layers just a little bit upslope from the Glentordan region. And for some reason, they appear less altered and are very visually unique compared to what we see both above and below these layers. So I'm mapping the extent of them with sub-meter resolution imagery and determining their composition with a hyperspectral imager that's on board the Mars Reconnaissance Orbiter. And these layers, what are these one random layers? What are they? Why do we care about them? But they bring up a lot of interesting questions. How are they deposited? What are they doing here? Why are they less altered? And so just I'm trying to parse out one small piece of like the giant geologic history puzzle. And then from back here on Earth, I will be conducting fieldwork in Iceland with a NASA-funded proposal where we're looking for trends in sediments of volcanic rocks as they're transported away from their original volcanic source, transported through rivers and wind transportation, and eventually deposited in lakes, which is what we think happened in Gale Crater. Looking at the chemistry and morphology of these sediments using techniques that are relevant to rovers on Mars. And there's a big general disconnect between what we can do as a field geologist on Earth and what a robot on another planet can do with their own set of tools. So working on what similarities and differences we get between our interpretations as a field geologist and a robot geologist can help impact how we see the history of Mars. So that's my whole PhD in a nutshell. And in terms of career goals, very similarly to Tina, I am kind of in between deciding of if I want to work in a research center like JPL or if I want to go into academia as a faculty member at a university. My long-term career goal is I want to stay involved and eventually lead some of these large planetary science missions, not only just to Mars, but to other planetary bodies because they're also intertwined. And I'm also passionate about mentoring future students. I'm a non-traditional student. I went to community college before transferring to Western, and I didn't really grow up with any science role models. So one of my main goals is to kind of help make science less intimidating for people outside of the field and draw a more diverse crop of students into what we do, because planetary scientists are awesome and inspiring and very welcoming once you get to know them, and even before. Thank you.
All right, thanks, Amanda. The last question I have here is for Kathleen. This is a very interesting question to me, and that is, how does the private sector in Seattle and the region contributing to space exploration?
So there's quite a lot going on there. There's numerous different companies, different types of companies doing different things and contributing in different ways. So I'll just kind of like go down a quick list to start. So you could talk about launch providers, and that would include like SpaceX out of California, but also Blue Origin based out of Kent, that are providing the rockets that take things off Earth. And then there's support services surrounding that, like Spaceflight Industries is a Seattle company that helps anyone who has a little satellite and wants to get it onto one of these spacecraft, or like wants to get it off the Earth. They're not necessarily going to be like, they're not a Perseverance rover. They can't just go and commission their own launch vehicle. They have to maybe piggyback with a bunch of other little satellites to get up off the Earth. So the spaceflight industry helps with that. And then there's people building commercial satellites. SpaceX, for example, has a facility in Redmond that's working on, it's called the Starlink constellation. And as an aside, some of the issues surrounding that are a great example of why commercial space needs planetary scientists involved and astronomers. Some of those Starlink satellites have been cause for pretty significant concern in the astronomy community because of their potential for interfering with ability to make observations. And it's not because the people at SpaceX don't care, it's because they just didn't know that would happen. And so having planetary scientists involved in decisions like that from the start, or astronomers, could really like lead to a better path. Then as well as commercial satellites, there's also companies that provide widgets for NASA and other larger companies. Example is Tethers Unlimited. One of their products that they work on is momentum transfer tethers designed to boost orbits and do other things. So basically people who or companies that make small parts of bigger missions. And then there's people providing engineering support services for planetary science missions, and that's my company, First Mode, does a lot of that. We've done structural and thermal design work for Europa Clipper. I got to do a design for a very small bracket that will be going on Europa Clipper. It was exciting. Yeah, so that's another thing that we do. And then there's also companies delivering hardware to NASA centers. My company is going to be starting work on an aperture cover for Psyche, which is a mission to, it's basically a stripped core of a protoplanet. So by going to Psyche, we can potentially learn more about the Earth's core than we can by trying to look at Earth, because there's all this rock in the way on Earth, but Psyche is just the stripped core. So we're sending a mission there, and my company is providing a cover for one of the apertures on one of the instruments on that spacecraft. And then finally you have prime contractors, which historically in this area would mean like Boeing. So it's the giant companies, the ones that might take ownership of a full larger mission. And historically that's been limited to a very small number of companies. In the launch vehicles part of the industry, there's been just like a lot of disturbance to that model with new companies like SpaceX and Blue Origin, just really like throwing that balance off and opening things up to smaller, younger companies to try to take those bigger, take larger roles in owning missions, as well as just providing these like smaller support bits of it. Locally, we have Blue Origin as a prime contractor for human landing system for Artemis, our next crewed mission to the moon. And as briefly mentioned earlier, First Mode would like to sort of enter into that space as well with some of the proposals that we've been working on and things that we work towards long term. So we really see a lot of potential for larger and larger roles for private companies, and hopefully it can end up being beneficial for all. Let NASA continue to do things that NASA is awesome and excellent at. Let private companies be able to contribute their skills and expertise as well. Yeah.
All right, thank you. Thanks, Kathleen. And I know that we're gonna move into the Q&A section right now. We've got some questions queued up here, and I know that Tina, you have to go. So let me say thank you so much. You've done an awesome job. I really appreciate you taking the time. Thank you.
Thank you so much. Have a good one, everybody.
Bye-bye.
Thank you, Tina. Bye.
So I want to thank everyone who's sent in a question, and now we'll start going down through there. And I think what I'll do, Melissa, is I'll ask the question. I'll let you decide who's the best to make the answer for that particular question, if you don't mind doing that. The first one is, what is the zoom capability of the Mastcam-Z cameras?
Yeah, well, I'm going to throw that one to Darian as the one who's actually the most involved with planning for the images that Mastcam-Z is going to take. I know that on Curiosity, we've had one eye at 34 millimeters as the kind of wide angle lens and one eye at 100 millimeter focal length as the telephoto lens. And I know that Mastcam-Z can exceed those ranges on either side. But Darian, do you know what the operational limits are going to be to the zoom?
Yeah, I know. I believe our operational limits are going to be from 110 millimeter focal length to 26 millimeters focal length. So we're going to be able to go a little closer and a little farther than we have been before. I wish I could say that in terms of, you know, times resolution, what we typically think of resolution 2 times, 4 times, that sort of thing. We're so used to thinking about it in millimeters focal length that that's kind of the numbers that I have lodged into my head. But yeah, 26 to 110 as opposed to 34 to 100 is what we'll be working with for the new mission. So we'll be able to get in, you know, notably closer than we were before, and also zoom out farther to take some much bigger landscapes, which is really exciting because we do run into, you know, situations with Curiosity where fitting everything into our field of view can be difficult when we're working with 2 fixed focal lengths. We have 2 fixed zooms, and sometimes it's like, oh, I wish we could zoom in a little bit closer, or oh, I wish we were a little bit further out so we could get more of this in the field of view without having to take many more images for this mosaic. So it should ideally give us a lot more freedom with our observations, and it's something we're excited to play around with and to look at.
Okay, so next question. So what has been the most surprising geological discovery on Mars thus far? That's from Marlene.
Ooh, that's a great question. And I think that everyone on the line here might have a different answer. The most surprising geologic discovery on Mars ever was, in my history and as a planetary scientist, getting into this as an undergraduate in the early 2000s, that was right around the time when the Mars Global Surveyor spacecraft arrived at Mars and started returning for the first time high resolution images. And it was a huge discovery for that mission to take the first pictures of what were definitively sedimentary rocks on the surface. Before that, the orbiters that were taking images and even the landers, the Pathfinder lander, the Viking landers, had all landed in places that were full of volcanic rocks. And so Mars was thought of as an entire world that had been covered with volcanic lava flows and then beaten up by impact craters. And maybe there were some massive floods that scoured the surface, but nothing like rivers and lakes and deltas and kind of the nice, quiet, long-lived ponds of water that would be required to host life. So when those images came back showing nice, obvious sedimentary layers in the rocks, that was when our whole thinking towards Mars shifted, that Mars could have been a place with much kind of calmer, quieter, long-lived water on the surface. And that's really the starting point for starting to envision Mars as a world that hosted life.
Great, thanks, Melissa. And I think in the interest of time, I would love to hear from the students on that one, but I think because there's some more questions and we have to get to them in the next couple of minutes here, I think I'll move to the next one. The next one is it necessary to protect the sensitive instrumentation on Perseverance from radiation on its way to Mars? And if so, do the protective strategies have any implications for human travel in space?
Yeah, I'm going to throw that one at Kathleen, since she works most broadly with spacecraft integration into various components and these kind of nefarious forces in space that affect every aspect of the spacecraft. So yeah, Kathleen, tell us about spacecraft hardening for radiation.
So I don't have like any very detailed answer for this, but yes, radiation's an issue. On Mars, we have some protection, but not like on Earth. We don't have a good magnetic field, except in some very specialized regions. Yeah, I don't have a very good detailed answer on that one. Sorry, Melissa.
No worries.
Yeah, that's part of the extensive testing that Darian had been talking about too. Is how are these cameras and the different components of the rover going to hold up in that harsh radiation environment? So there are tests where they subject the spacecraft components to Mars-like and space-like radiation, in addition to putting them in a vibration chamber and shaking them so that they undergo the same kind of jiggling that's going to happen during launch. So yes, absolutely, we have to take that into consideration, and Perseverance is radiation hardened.
Great, thanks very much. Let me skip to this one. I want to hear the panel's impression of this important question. Is there a better gender balance in the NASA Mars work than in most STEM fields, or is this panel a reflection on the power of having a woman scientist leading the team? I'm interested in your impressions.
Yeah, I would say that planetary science in general has a better gender balance than a lot of STEM fields. Actually, biology, I believe, across the board has a balance tilted towards female participation. Most biology graduates now are something like 60% female nationwide. But in planetary science, I think because we draw interdisciplinarily from geology and from physics and astronomy and chemistry, that we are, in general, get a more diverse field than pure physics and astronomy disciplines, for sure. As for the balance that's represented on the screen today, this is just a snapshot in time, so the statistics of small numbers, and we've had periods within the Mars lab over the various years where we've had a balance and a makeup of the group in one direction or the other. So this is just a snapshot in time that you're seeing right now, but integrated over the years that we've been together, it's been a good gender balance with a lot of other diversity as well.
Great, thank you. That's a good question. So the next question is from David, who asks, I'm curious to know what you think your reaction will be when the cameras turn on and you get to be among the first people to look around and see the surface of Mars through the eyes you helped design.
Love that question. I'm going to throw that one to Catherine.
Yeah, I think there's going to be a lot of screaming. That's usually traditional for when we get our first image back. This mission is probably going to be different. We are in the middle of a global pandemic right now, and anyone's guess as to where that's going to be come February. So this may be a little bit different in that there might not be a room full of people jumping up and down and screaming all together. It may be a little bit more socially distanced, but I think that in some ways that allows for there to be greater participation of the entire world with the launch of Perseverance that is coming up very soon. That was something that I know at least a couple of us were planning to go to, which is not happening now because of COVID. But with that, NASA and JPL have created a much more extensive public engagement type thing and a show basically to put on for when the rover launches, and hopefully that will continue with the landing as well if we're still in this situation where we need to remain physically distant from each other. But I think regardless of who we are with in person, there will be a lot of excitement individually and as we connect with each other on things like Zoom.
All right, thanks. Good answer.
Awesome. Yeah, Brad, let me just add one more thing on top of that.
Absolutely.
Everyone here is obviously going to have a special connection with those first images that we see when Mastcam-Z opens its eyes and takes a full color panorama. And so we'll have that kind of depth of experience and understanding in seeing those images. But aside from that history with the cameras themselves, we won't have any special access. And this is something that NASA has been very good at with its missions over the past decades, is releasing the data to the public immediately. So when the rover takes its first pictures and sends them back to the Earth, they're going to be available on the NASA Jet Propulsion website for the entire world to see at the same time that the science team gets access. So that it's not that we're going to be the first people to see these. Everyone on this call, you all can be the first people to see these images as well. It's really for all humanity, which is something that makes NASA's space program unique.
That's a very good point. I've certainly taken advantage of that over the years myself, for sure. Okay, next question is from Tony. Given the current state of our understanding of Mars, what do you think is the probability that the missions will show evidence of past life?
Yeah, that's the $1,000,000 question. What is the probability? It's non-zero, which is why we're doing this. And I'm sure that there are betting pools, you know, with odds on the side, but I don't think anyone really knows what our chances are. We just know that there is a chance. So the missions up to this point have shown us more and more detail about these sedimentary rocks, what they mean for the history of water, how long water would have had to have been on the surface. The Curiosity rover, one of its big discoveries was interpreting some of the specific aspects of the water that had been present. We know that it was water of a neutral pH. It wasn't too salty. It wasn't too acidic. It had the nutrients that life required were present. So the water on Mars was good enough to drink, and all of the nutrients that microorganisms need to thrive were there. That we know definitively. And we know from our experience on Earth what the building blocks of life are, what the components that life needs to thrive are, and we know those were on Mars. So that means there was a chance that life had emerged on Mars and took hold, and that the rocks on Mars preserve evidence of that life today. But what the odds are, I don't know. Your guess is as good as mine. So that's why we've got to go find out. If any of the students are placing bets on the odds, let us know if you think if you have a specific 79.6% chance of life on Mars.
That's good. Well, that unfortunately is about all the time we have for questions. I definitely want to say thank you again to everybody for showing up and hanging in there with us. And I definitely want to thank the panel. I want to thank Melissa and all the students. I want to thank SJ from the alumni operations for hosting this. I want to thank Landon for the technical support. Definitely want to thank Sabah, and I will give each of them a chance to wrap up real quick. But before I do that, I just want to say that I just never get tired of interacting with students on this campus and the research they're doing. It's something that I look forward to every year whenever there's an event of any kind. I love going. I love hearing these stories. I love hearing the interactions. It's a big part of why I myself came to Western, is this kind of thing. And I definitely heard the message about funding for keeping students on campus in order to do research. That's for those who are still left on the call, that's a big part of the message that we talk about with people when we go out to lunch with them and we chat about what's going on at Western. That's always a topic that comes up. So it's near and dear to my heart as well. So thank you for bringing that up. And I also want to thank Melissa for all her incredible mentoring. And there was one mention early on about cloning and making more Melissas. Well, one way of looking at what's going on here is that's exactly what's happening. That each one of you carries with you a piece of the mentoring that you received here at Western, and specifically from Melissa. And I believe that you will carry that forward, and that you will provide another generation of role models for this kind of work. So I want to thank you all so much for being engaged and taking the time to do all of this. And so I just want to make sure that I thank you all once again. You've been amazing. And I want to turn that over to Melissa if she has any final thoughts, and then she'll turn it over to Sabah.
And I just want to thank all of the students for taking the time out of your jobs and your PhD studies to come and share your work with this larger crowd of people who care about Western and who are connected to Western. I'm so proud of you all. And you've all talked about the great opportunities that you've received at Western, but you wouldn't be where you are if you hadn't have worked hard and seen that those opportunities were worth taking advantage of. So I hope you all feel really proud of where you are and where you're going, because I know I certainly am. Thanks to all of you.
Thank you, Melissa. I too, would like to thank you for your work, for what you have brought to Western, for being a wonderful role model for our students. I am so proud of our students and now our alums who are doing wonderful things upon graduating from here. Thank you, and thank you for what your your contributions. Finally, thank you so much for joining us today. You know, as you have heard, the margin of excellence that we are trying to seek would not be possible without the support of our alums and our donors. There are limits to state appropriations. There are limits to research funding, and particularly in an environment where we are today, both in the state and nationally, you know, that there are some significant barriers to funding innovative work like the work Melissa is leading. Your support of our students, your support of our programs is so much appreciated and so fundamental to excellence in teaching, learning, and scholarship that we are trying to attain at Western. So thank you for joining us. I hope you have a safe and enjoyable day and week. And we look forward to seeing you on one of these webinars here soon.
Thanks, everybody.